Hello everyone, and welcome to another episode of Math with Audrey. Hopefully you guys are doing all right, and hopefully the day after Easter is not so crazy for you guys as it is for me. All right, so business back into play as promised. We are going to work on distance, rate, and time. We're going to be doing some word problems. Not wood problems, word problems. That is an R. All right, so hello, David. How are you? Hello, Tony. Hello, everyone. Welcome on in. Okay, so as promised, we're going to be working on distance, rate, and time word problems. This is definitely a problem that's going to be on the ASVAT. That's going to be on the AccuPlacer, on the GED, and some of you guys that are taking either pre-algebra or algebra 1, maybe not so much algebra 1, but definitely pre-algebra. This is in there as well as some of your statistics and probability sections, okay? So you will see it. If you don't see it, that means someone else is seeing it. If you know of anyone that is going for their GED, that's going for AccuPlacer, that is going for some T's or ASVAT, have them chime on in because this is what we're going to be working on tonight. I have a total of 6 questions and 6 questions only. All right, so let's zoom in to the whole process. Now, you probably have seen this triangle once before. So some of you guys may have seen it in another instance, especially for science. If you guys were working on a little bit, and usually it's mass, then it's density and velocity or volume. All right, so you've probably seen that a little bit, especially if you are doing calculus. That's in there as well when you're trying to do the derivatives. So, and you'll have like acceleration instead of rate or speed. And then you'll have like velocity. So you will see this multiple times. It's never just a one and done type of thing, right? About fractions soon. Fractions was last night or the night before. So you're going to have to go to my YouTube channel, because I already did fractions. Yes. Yep. Still have some of the notes around here somewhere. Okay. So if anything, we're going to be taking a look at the first one. So the D is your distance. The R is your rate or speed. And T is your time. So here is our first word problem. Let's kind of take a little zoom in. Oops. There we go. Okay, aircraft carrier made a trip to Guam and back. The trip there took 3 hours and the trip back took 4 hours. It averaged 6 kilometers per hour in the return trip. Find the average speed of the trip there. Okay, that is huge. We're not looking for the total trip. We're looking for the average speed of the trip going there. All right, that's huge. So if we take a look at it, we kind of have to like look at what happened going there as well as what's coming back. So if we look at it, it says the trip took 3 hours there and the trip back took 4 hours. Okay. It averaged 6 kilometers per hour. So that's kind of like a little bit of a distance, don't you think? So that's important. Okay. But that was on the return trip. So let's say going there versus coming back. Seems like that's kind of hitting. So since we're looking for find the average speed, that's going to be your rate. Your rate is your R. Okay, most people know it as the average speed. So that means we're going to take our distance and divide it by the time. That's why you have this little triangle. So if you're looking for the average speed or the rate, that means you have to take your distance divided by your time. If you're looking for the time, that means you're taking your distance divided by your rate. And if you're looking for the distance, that means you're multiplying your rate times the time or your average speed times the time. So that's how you kind of use that little triangle. All right. So if we're looking at it, going back took 4 hours. And the average, which was my distance, okay, kilometers per hour on the return trip, so we got 6. But going there took 3 hours. So now we got 4 times 6, so we're looking at 24 divided by 3, okay? So if we want to know what was the average speed of the trip there, 24 divided by 3 will give me 8. So it was 8 kilometers per hour, okay? Definitely have to put that in there as well. Let me shrink that down a little bit so we can fit everything there. Okay, yes. What are they doing in Guam? I don't know. Oh, you lived in Guam? Yes. A lesson about fractions. Okay, we already did that one. Strap fractions for a year. Oh, okay. 16 to 24-year-olds for the federal program. Okay. It was add and subtract fractions for a year. Ugh, why? Why? For a whole year? Well, yes, and I bet you were getting paid for that. Okay. So, now we're actually going to be taking another look. So we have a passenger plane made a trip to Las Vegas. Do we feel better about Vegas instead of Guam? Is that better? Guam is a nice place. Okay. Okay, so now we're making a trip to Las Vegas and back. Okay. On the trip there, that's vital, it flew 432 miles per hour. And on the return trip, it went 480 miles per hour. So how long did the trip there, okay, that's key, take if the return trip took 9 hours? Okay, so let's think this through. All right, so again, we're going to have our return over there. So we're looking at my return. And I know you can label it any which way you want. I just try to use the verbiage that they use. So we got the return versus there. Now, on the return, they're saying it went 480 miles per hour. Okay, miles was my distance per 1 hour. But they said the return trip took 9 hours. So that means we're looking at 480. That's how much is 1 hour. But we need to multiply that by 9 because we want to do a little bit of solving that deals with the 9-hour return trip, right? But over what it took for it to flew there, which was 432 miles per hour. Okay, that's how long it took for, or the distance for there. So we got our 432. So 480 times 9 gives me 4,320 over, how convenient, 432. hopefully you see it. How many hours would it take? What do you think? Put it in the chat. How many hours? Hello, John. How are you? Hello, Rainbow. Thank you for your answer before. I did see it. I'm sorry I didn't mention you. Okay. So we got 2 people with 10. Jackie with 10. Don't ask me why I'm saying your name. I have no idea. Pug! How are you? Hey, Cheryl. Good. Rose. Yes. April. Yes. Welcome in, guys. Welcome in. Welcome in. Welcome in. Yes. So we have a total of 10 hours. Okay. Why is it return divided by there? Well, I'm using the terminology that they're using. That's the only reason. Okay. Hey! I think it's but I always mess it up. Bakata? I haven't seen your name in a while. Hopefully that's it. Hopefully you're doing all right. Okay. Good. So we have those. So now, this is the one that everyone loves. Everyone loves this word problem. Everyone. Everyone. Even your granddaddy. They love it. Okay. So, a cattle train. I'm doing well. I'm doing well. Okay. So, we got 2 trains going on here. We have a cattle train and a diesel train. Remember those lovely word problems as one train is going in one direction and another train is going into another direction, and when are they going to be at the same stop? Yeah, remember that? Here we are. You're so welcome. So, a cattle train leaves Miami. Do we feel better about Miami? All right, it's hot, it's sunny. All right, and travel towards New York. How are we feeling? Feeling okay? All right. So 14 hours later, a diesel train left traveling at 45 kilometers per hour in the effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up. Can't even read today. All right, so what is the cattle train's average speed? So average speed, that means eventually we're going to be doing what? Multiplying or dividing. Okay, if we're looking for the average speed, let me come back to this. If we're looking for the average speed, will we be multiplying or dividing? Okay, multiplying or dividing, what do we think? And remember, question marks are answers as well. Okay, so I have someone with division. Thank you, Joan. Dividing. Thank you, Cheryl. Appreciate it. Any more brave souls? Cook. Hey, Cookie. Divide. How are you? Okay. Anyone else? I know there's 3 people that said divide, but I want to know what you think. Okay. Distance times time. Okay. Now for the average. Anytime you hear the word average, you should be thinking division. Okay. Sometimes those particular words, good. Okay, sometimes those particular words kind of helps that. All right, so anytime they're saying average, when you think of an average, you're usually adding up the numbers and dividing by the number of numbers, like a mean. Okay, so we are going to be doing some dividing. All right, so Jen gave us a breakdown. Someone else earlier gave us a breakdown of how to figure it out, which is awesome. So here we go. So if we take a look at it, we got 2 trains. We know that we have the diesel train, and then we have, kind of jumped ahead there. So we have the diesel train, and then we have the cattle train. So for our diesel train, they said that it was 45 kilometers per hour. And then they said for how many hours? They traveled for 4 hours. Okay, so that means we have our 45 times our 4. So we can figure out our diesel. So that gives us 180. All right, so that's how many kilometers in 4 hours. So that's their distance. Now, for the cattle, it seems like they kind of told us 14 hours later. So it left before the diesel. So how many hours are we talking about? Okay, you could use Jen's answer as a reference. So how many hours? If that cattle train left before the diesel train, but we're also putting into perspective the 4 hours that the diesel train traveled, how many hours are we thinking of? Okay, Joan, being the sacrificial lamb, is saying 18. Drop the question mark, Joan. Good job. All right. Because there were 14 hours ahead. And if they caught up, if the diesel caught up with the 4, we're looking at 14 plus the 4. So we're dealing with 18 hours. Okay. So now we want to find out what is the cattle train's average speed. So we already have our distance. Boom. That'll be here. We already have our time. Boom. Which is the 18 hours there. And 180, to make it very simple, 180 divided by 18 will give us our lovely 10 that a lot of people were talking about. And it will be 10 what? Since we are dealing with kilometers and hours, it'll be 10 kilometers per hour. I forgot to box my other answers. Shame. Okay. It is a little bit of physics. It is a little bit, which is usually they have like one, maybe very, very slim, but they usually have one question similar to this on the ASVAT, Army and Air Force I've seen so far. On the ASVAT, they always have like one distance problem, and I think there's one on the GED, but not this one. Kind of similar to the Vegas one, but not so wordy. Very similar to that. Okay, so that's the reason why I'm like kind of going through it a little bit, just so we can be able to do what we need to do. Okay, it's about the basic physics as you can get. Yeah, I was telling you, John. I miss when my physics questions look like this. Oh, I know. Now it's like sacrificial lamb. Oh, I do not miss physics at all. That was just me. But for others, it was an awesome thing. All right, so how are we feeling? Hello, Tim. How are we feeling so far? Seems like pretty much, okay. Refreshing the brain up a little bit. All right. Okay, got 3 more for you. Let me see if I can put this in here. And I might be... All right, so here we are with another one. So we have Jose left the White House and drove towards a recycling plant at an average speed of 40 kilometers per hour. Rob left sometime later, driving in the same direction, at an average speed of 48 kilometers per hour. After driving for 5 hours, Rob caught up with Jose. So how long does Jose drive before Rob caught up? Marinate on it. What do you think? What do you think? Okay, let me give you some time to think. All right, no stress, no pressure. Let's see what we can get. Think about what you should either underline or highlight. What is important? Okay, thank you so much for the follows. I appreciate it. It's America? I want to say America. And Gloria. Okay. Now, if you feel like I'm a little stuck, put a question mark. It's perfectly fine. This is a safe space. This is not Squid Games. I'm not going to off you by having the wrong answer. Okay? It's perfectly fine. Okay? I have, is it questions, girl? Or Quinn's girl? For 6 hours. Thank you. All right. Thank you. I'm coolin'. Thank you for your honesty, Raquel. Thank you for your honesty, Cookie. Thank you for your honesty. Okay. And we all know word problems. It all depends on how you perceive it, how you envision it. Okay? So word problems is a challenge, and it's perfectly fine. Because sometimes I have to read things multiple times just for me to be like, oh, okay, that's all they wanted us to do. Why didn't they just say so? Okay. Gonna go over it in about 30 seconds. Not to stress, not to pressure. But while you're waiting, if you want to tap, you can tap. I will greatly take those if you want to. If you don't, you want to sit and chill and listen to the jazz, go ahead, sit and chill and listen to the jazz in the background. Okay. Well, thank you for your honesty. You know, I'm cool and trust me, it's not. Because right now we're not doing any conversion. We're just using it as a unit. I wanted to, change some things up to incorporate as many. Okay. So yeah, we're not really like doing a whole lot of conversion. Okay. Cool. Thanks. All right. Okay. All right, Logan. Logan! How are you? Okay. Yep. Kilograms or kilometers per hour. Yep. But since everything is either kilometers or hours, we're not really doing a whole lot of conversion. Okay. We're not going like, say, to miles to minutes or anything like that. Okay. Cool. All right. So what's important? One, we got two people here. We have Jose, and Jose is at an average speed of 40 kilometers per hour. Then we have Rob, who left some time later. Okay, same direction. That's important. Okay, they're going into that same direction, but Rob had an average speed of 48 kilometers per hour. So after driving for 5 hours, Rob caught up with Jose. All right, so that's 5 hours for Rob. And they want to know how long did Jose drive before he caught up, before Rob caught up. Okay, so let's think about it. So we can figure out Rob's distance. Okay, so we know in the same direction we have 48 kilometers per hour, and he drove for 5 hours. So right there, we can get this. I'm going to put in my boy Rob, and we have 48 kilometers per hour, but we're talking about for 5 hours. So 24, so 240. So this will be my kilometers, okay? That's Rob. Now, we're saying that Jose drove an average speed of 40 kilometers per hour. So we can use, since they said the same distance or same direction, so we can use this as my D. If we want to use our lovely triangle. Okay, this is my D, this is my average speed, this is my time. So that means we can use that 240. They gave us our S, which was 40. And we're doing this to figure out our time. So if we're looking for time, cover that up. That means we're taking the distance divided by the speed. So I notice when I get 2 zeros at the end, I can cancel it out. So instead of me dealing with larger numbers, if I'm doing mental math, I just have 24 divided by 4. And 24 divided by 4 gives me 6. But 6 what? 6 hours. Because that's my time. Okay, good. Good job, guys. Good job, Val, Sandra, Jen, as normal. Logan, how did you get the 6? Sandra, hold on. There's some other stuff that's going on. Yep. So, Logan, do you see now how she could have gotten the 6? So first we had the 48 times the 5 hours that was driven by Rob. And since they were going in the same direction, we can use that 240 distance. Awesome. Good. Sorry, I had to scroll down. All right. Awesome. Nice. Okay. 2 more. 2 more. You're like, and that's going to be it for tonight? Maybe. Maybe not. We'll see. I might throw a little trig your way. What? Trig? She said dangerous. All right. What's that? They're both leaving the White House. Yeah, that's cute. All right. So Ryan left the Science Museum and drove south. Gabriella left 3 hours later, driving 42 kilometers per hour. Sorry, my lights are like starting to flicker, and I don't know why. I paid the bill. Maybe not in full, but I paid something. 42 kilometers per hour faster in an effort to catch up to him. After 2 hours, Gabriella finally caught up. Find Ryan's average speed. Okay, let's see if you guys can get this one. See if you can set it up. Okay, Sandra saying 28. This is the first time I've ever seen someone that says their name is Beaver and they're following me. You guys are hilarious with your names. I just want to let you know that. Hilarious. Ay, ay, ay. Okay. Drove south. Final answer. He drove south? Hello, Sarah. So I was like, he drove south. Okay, not a problem. Not a problem. All right, let's see if we can break this down step by step. And we got Logan with since 28, and Ryan and Gabby must have broke up. Yeah, you know, friend zone is a hard thing, Sarah. It's a hard thing. Some people just can't take it. You know? You know, a lot of things happen in the club nowadays. All right, so let's see. Okay, so Science Museum, it all happened. Okay, so Gabriella left 3 hours later. All right. So if we got Gabriella leaving 3 hours later, she drove 42 kilometers per hour in an effort to catch up with him. So that means there was a distance. But then they mentioned this. Gabriella caught up 2 hours later. So right now, it seems like with Ryan, if I may, Ryan's got like a good 5 hours before she caught up, right? But then, looking at the distance, because they didn't say anything about Ryan's distance, didn't say anything, right? But obviously, if she caught up to him, but we can't assume. But if we're looking at this, what Ryan drove, plus what Gabriella has, and all this is stemming from 2 hours. Okay? So we kind of want to find Ryan's average speed. So I can kind of look at it this way. If I distribute this to, I got my 5R is equal to 2R. And remember, there's more than one way of us figuring this out, right? I just felt like taking it algebraically. So if that's the case, I'm going to subtract my 2R. So my R's cancel. So 5R minus 2R gives me 3R. So this is all based off of Ryan. And it's going to equal to 84. But if I divide both sides by the 3, I will notice that Rai, what does that be? 28. So we were looking for his average speed. So it's going to be 28 kilometers per hour. And I know there's probably a simpler way, but this is what I got. All right. So, hey, Michael, how are you? All right. So we have to take into account So Ryan left first. Boom. Forget you, Gabrielle. Gabrielle's like, Ryan, your jacket. Sorry, I couldn't resist. So Gabriella, she left 3 hours later. Like, he left. Like, Gabriella, what were you doing for 3 hours? You're like, you know what? I wanted to come to the science center, so I'm going to sit in the science center and I'm going to have some fun. I don't care about Ryan. I came to see if I could electrocute myself so have my hair stand up on end. That's what I want to do. So I'm going to have fun for 3 hours. Then driving 42 kilometers per hour faster, speeding up like a crazy person, all right, in efforts to catch up to him. Then after 2 hours, she did catch up to him. So that means there was like a good 5 hours that Ryan was nowhere in sight of Gabriella. That's where the 5 came from. Yes, the 3 plus 2. That's where that 5 came from. But since we're looking at Ryan, we don't know what his distance is. They didn't tell us anything, right? So we're looking for that. We're looking for that average speed. But we know that hers was 42 kilometers per hour. And we know that all of this was happening in a 2-hour period. So if we distribute the 2 to the R, we get 2R. Distribute the 2 to the 42, get 84. And then now we're in quest of isolating our variable. All right. So we need for both of these R's to be on the same side of the equal sign. So you can subtract that 2R because you already got the 84 over here. So if I subtract the 2R, 5R minus 2R, that gives me 3R. Bring down the 84. So now I want to isolate the R. 3 times R, do the inverse. Okay, divide 3 out of your life. So we divide both sides by 3. 84 divided by 3 gives me 28. Okay. Right? Right, Michael? Gabby is like, man, Ryan must have loved that jacket because she drove some distance. All right. Cool. Got it. All right. She's speeding like a mad person. All right. Did I add 42 and 84? No. Okay. I took the 42 and multiplied it by 2 to get the 84. Okay. All right. So that's Mary. Do you see how I got the 5R? I'm trying to catch up with all the stuff. Okay. All right, good, good. So that was wrong. All right. Okay, awesome. All right, one more. I feel like I should take a collection of all these word problems to see if we can have some kind of live action. Oh, I need sleep. Anywho, here we go. Last one. So a submarine left Hawaii. Okay, we went to Guam, Los Angeles, a little bit of little Vegas. We're at the White House. You know, we could be at the Science Museum. Now we're in Hawaii. How are we feeling for the last one? All right, so a submarine leaves Hawaii 2 hours before an aircraft carrier. The vessels traveled in opposite directions. Okay. The aircraft carrier traveled at 25 miles per hour for 9 hours. After this time, the vessels were 280 miles apart. Find the submarine's speed. Ooh. You should know this one. Oh, you were stationed in Hawaii? And there's Michael. One more, please. Sandra is on point. Oh, and there's Joe. And how are you, Joe? It's been a minute. I like when I recognize names. I like put you guys out, be like, hey, what's up? Okay, Icy Mike is telling me 5 with a question mark. Why the question mark? Good. Glad you are. Pulling out the information. Good. Yep. Every time you guys have word problems, always pull out the information. Stop it. Always pull out the information. Okay? Underline, highlight if you can have a highlighter around you. Okay? Do we assume no current? Yes, we can assume no current. I know, right? That's when we come into the whole. They start in relation to each other. The same location? Yes, they started the same location. Okay, Logan saying it's 5 miles per hour. Yep. Alaskan fisherman, I feel you. I used to have really major trouble. It wasn't until I became a teacher because it kind of forced me, and it wasn't like you can, I'm not going to teach that because I'm not sure of it. You had to teach it, so you had to understand it. Yeah, I get you. Okay, I got 6.1. Ruben, hello. About 5 miles per hour. I'm positive it's 5. All right. There you go, Icy Mike. I like that. All right. So I got like 3.89. We got John. This is those real light applications. Yeah. I like how you put quotes around it, John. You're my new best friend. Yeah, this is how we're supposed to do real world application. Oh yeah, let's make the word problems more socially, acceptable. Let's change from one name to Gabriella. Let's make it more exotic too. Yeah. I've been teaching for a while and I've noticed so many changes. It cracks me up. All righty then. All right, so here's the big pieces of information. All right, so we need to find the submarine speed. So we don't know what that is. So I'm going to use that as my unknown. So I'm just going to say subs speed. All right, now, basically, just like with, I totally forgot who asked me the questions. Not Ruben. Crash. Just like what Crash was asking, like, are they coming from the same position? Are they going all over the place? Blah, 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 blah. I know. It's crazy. Always like, when are we going to do this in real life, kid? I know. I get it. All right, so we're looking at what they gave us. So they gave us, all right, there was 2 hours. The submarine traveled. Okay, they were going in opposite directions. And we also had something with the aircraft carrier, but the aircraft carrier traveled at 25 miles per hour for 9 hours. So, time-wise, if I may, the subs time is going to be this 9 hours plus this 2 hours. So we have this 9 plus 2. That will give me 11 hours. All right. So we're trying to figure out the submarine's speed. So if we're looking at the submarine is 11x. That's what I'm saying. But then we have the aircraft carrier. And they're saying that the aircraft carrier, they're telling me 25 miles per hour for 9 hours. So if I have my aircraft carrier, we're going to look at its distance. And I'm going to call it AC for the distance. So that was 25 times 9. And 25 times 9 gives me 225. So 225 miles. All right. Because it was 25 miles per hour and they traveled like 9 hours. But they're saying after this time, the vessels were 280 miles apart. So with that being said, let me put this little 2 cents in here. So if I'm saying the average speed, we're talking about 11 hours. We don't know what the average speed is, so I'm going to say 11x plus this lovely 225. That's going to equal how far apart they were, which is 280 miles. So in order for me to find my average speed, or my speed, not my average speed, my speed, which is my x, I need to isolate my x. So I always kind of like think of it like a club. Okay? I want to subtract my 225 on both sides because I want to isolate that x. Boom. So I have my 11x is equal to 55. So if 11x is equal to 55, that means x is going to be equal to 5 because I had to divide both sides by 11. So my x is equal to 5. 5 what? 5 miles per hour. So that was the submarine's speed. All right. I know. I didn't make this up. Oh, okay. Cool. That'll be so awesome. Love it. Yes. All right, so that, I know this would be really short if I just end right here. You think I was just going to end right here? Yeah, I was. But I know I'm not. Because I was actually, here we go. Not a problem. Not a problem. So that's like the main thing. As long as you understand what is, and sometimes the questions is a little bit easier than these, believe it or not, when it comes especially to the ASVAT and to the AccuPlacer. You know, like I said, most of the time it'll be distance, rate, and time. Sometimes it will be mass, density, and volume. I always want to say velocity and volume. But no matter what, just remember, if you're looking for your speed, you're going to take your distance divided by time. If you're looking for your distance, you're going to take your rate times your time. And if you're looking for your time, you're going to take your distance divided by your rate. Now, they might give you some extra hours that you have to fill in, just like how we did for this problem. We had to do a little bit of multiplication before we did the division. That's where you're probably going to might have to incorporate that into your solutions. All right, so where do I get my material? I stole it, Anthony, because I'm a teacher. That's real thug life. No, This material I actually got from a textbook, one of my old textbooks. And I've been in the classroom for 20 something years, and before I left, I made sure I stole a couple textbooks. So I might be going to jail. But I have to like make up a harder story than that once they get me caught. But I'm just like, by the time I'll be 80 years old, I just won't care about anything anyway. But so that's basically, I got it from there. What? It's over less than an hour? I know. Like, what are you going to do with your life? No, but someone did ask me to go over system of equation real quick and systems of inequalities. And I'm actually going to just add that to this lesson real quickly. Probably just do a couple of problems of each, and then I will call it a night, right? Not like I don't have anything else to do. Let's see. I'll probably do some naked math. Not math naked, but just general. Like how we can find our things. Not graphing. Substitution, elimination. All right. Here we go. Looking beautiful. And if you like my lovely notebooks, I actually designed this notebook. I got sick and tired of my students not having their stuff organized. So I literally put down like 100 pages. Some of it's dots, some of it's the grid side. Also have the formula section, the step section. So I've just been like trying some things out. And in addition to it, if we have students that are not strong with multiplication, I have what's called factor sheets, which will help with factoring and also reducing radicals. I go from 1 all the way to 200, as well as I have some additional phases and reminders like rules of integers. Also have our, please excuse my dear Aunt Sally, the properties of inequality, exponents. We have like SOHCAHTOA. We also have volume and surface area, a little bit with sectors and arc lengths. I think some of you guys are working on that right now, as well as the unit circle. And in addition, just a little brain break. So if you like these and you would love to purchase your own, hey, that would be awesome. Come support me. I do have the link in my website. Being so aggressive with this today. Okay, I do have it in my website. Just have to hit my profile picture. And once you hit the profile picture, the title of it is The Ultimate Math Notebook. I'm a little facetious about it, but I just felt like there isn't anything that's designed for our upper, like our older kids. It seems like most of the notebooks that we have is really designed for elementary school kids. Even the multiplication chart in the back, the kids don't know how to read it nowadays. They really don't know how to read it. The struggle is real. But the factor sheet, they're able to get it a lot better. So, yep. Thank you for the taps. I greatly appreciate it. Show me the second to the last problem quick. One with Gabby. Thank you, Missy. Not a problem. Let's see if I can find it. Where is Gabby? Here's Gabs. Okay. And starting tomorrow, if everything pans out this evening, you can actually get a copy of all my notes. Okay. I'm selling those because I need a little extra cash. Just saying. The holidays is not a good time for tutors. Let's just put it that way. But I am selling like all my notes from the very beginning, including tonight's. So I am trying to put all of those on display. Michael's probably like, about time. You're welcome. All right. So yes. What is MAT? What is MAT? Chaz, what are we talking about? Like, what are you trying to say? What is math? Like, really? Don't have time for that. Okay, so I had it And now I don't know what I did with that. Oh, here it is. Okay, so let's do some system of equations. You can do it either with substitution or elimination. So this is going to be our first one. Let's say, we'll go with a little example. So we have x minus 7y is equal to 18. And we have 4x minus 14y, should put it a little bit better, is equal to 30. Okay? We can solve this one of two ways. Really, there's a third way, but that's just too much. It's too much effort because you have to make a graph. One of the ways we can do is called substitution. All right? Substitution is the hardest of the two ways. Time consuming. Because since most of you guys are going to be using this for an assessment, unless it's your classroom teacher that says, I want you to solve this using substitution, then you have to do the substitution method. But most of you that are watching this right now are going to be using this to pass Accuplacer, ASVAT, GED, what have you. So we always love our shorty of shortcuts. So one of the ways we can do is called elimination. We want to eliminate either our x or our y's. I feel like this is the art of war right now. You want to eliminate one of them. Which one would it be? Finish it. Sorry. So we have our x's and our y's. So we can figure out what do we want to eliminate. And it doesn't matter. Oh, MAT, Masters of Teaching. Master's Art of Teaching. Yep. I know. Certified teacher, baby. All right, so let's say, I don't know. Let's eliminate our y's, right? Why not? There is a 7. There's a 14. Zoom in a little bit more so you can see the 7 and the 14. All right, so I know through multiplication, it'll be easier for me to change this 7 to a 14 versus dividing everything, which could happen. But dividing everything by a 7 to make this 14 into a 7. That's gross. We're not doing that, right? So, but the only thing is I can't just multiply just the 7 by 2 to make it into a 14. I need to multiply this whole entire equation. I know, right? So now we're going to distribute. When you distribute, you multiply. So you're multiplying everything in that first equation by 2. All right? So let me unzoom a little bit. So we have 2 times x gives me 2x. 2 times negative 7y gives me negative 14y equals 2 times 18. That gives me my 36. Okay. Now, the equation at the bottom, we're just going to bring it on over. So that's my 4x, my minus 14y equals 30. Now, we're going to old school it to combine these two equations at the same time. Now, I could have, which I should have, multiplied everything by a negative 2 because it would be a little bit easier. And I'm going to show you why. Because 14 and 14, all right, same numbers. Minus and minus, they're the same signs. So in order for me to eliminate, one has to be positive and the other one has to be negative. So what I could do, since we're still in the early stages of it, I could pretend, just for giggles, that I did multiply by a negative 2. So that means this would be a negative 2. This will be a positive 14, and this will be a negative 36. Because in order for me to cancel out these y's, I need for the signs to be opposite, because what I'm going to do now is I'm going to add these two equations together. I don't know the whole science of it, but based on my experience, my students know how to add more than subtract. And if you really stop and think about it, a lot of people spend a lot of time with addition and multiplication than subtraction and division. Did that just blow your mind? Is the mind completely blown? All right? All right? Maybe. Okay? So now we have negative 2 plus 4 gives me 2x. The 14s, they cancel out to give me 0. But I don't need to put the 0y down there because I don't need it as a placeholder. I still have this 2x. Bring down my equals. Negative 36 plus 30. That will give me a negative 6. So now I have 2x is equal to negative 6. Boom, I could do that. That's easy. I'm going to divide both sides by the 2 because we're trying to isolate our variable, not 2x, just the 2. So we get x is equal to 3. By seeing x is equal to 3, that means I have a point of intersection, and the x value is going to be 3. Now I need to figure out what the y value is. So why not take this answer and plug it into one of the two original equations? Me personally, I would take the one that we just did, because it says x minus 7, y, is equal to 18. I can substitute this 3 that we solved in for the x. Then we have our minus 7y equals 18. We can subtract the 3 on both sides. So I got negative 7y is equal to what, 15? That's kind of weird. But here we are. All right. So then divide both sides by negative 7. Oh, she can't hear us. I can't hear you. Why can't I hear you? Oh, I think I know why I can't hear me. Everyone's like yelling, it's negative 3, Audrey. It's negative 3. That's why I'm looking at this like this looks so weird. That makes sense, because then this makes it a 21. Yes. Did you guys see me like hesitating? Like, wait, this does not seem right. So then this y would also be a negative 3. Okay. Because I'm sitting here and I see everything going like flash, 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 flash. And I'm like, what? Okay. Yay. All right. All right. So my point of intersection is a negative 3, negative 3. So, and here's the thing. I know I'm not perfect. I'm a human being. You know, if I was a robot, my voice would probably sound more like this. Don't you think? Okay, so, but when it comes to when you notice something like that, because I also froze and I was like, wait, that's not what's happening. And then as soon as I looked up, I was like, oh, wait, there's a negative. So sometimes when you do stuff and it feels kind of weird, it's not weird because you got a fraction. Sometimes it just feels a little weird. Always double check. There's nothing wrong with double checking. All right? Always double check with it. Okay, so you're probably not going to do substitution unless they have it as x equals or y equals. If they have something like this, you want to do process of elimination. You want to do elimination, definitely. So you pick what you want to eliminate. Do you want to eliminate the y's or do you want to eliminate the x's? All right, once you do that, you figure out if you got a point of intersection. Once you find one of your variables, plug it into one of the originals to find the other variable. Sorry, I gotta deal with the puzzle piece again. I never understood the whole puzzle piece thing. Like, does anyone know? Because I sure as heck don't. All right. So now, if it was inequalities, you're definitely going to need to look at the graph itself. Okay, so I'm just doing a quick sample because I'm not even sure if this person is even here, but here we are. So, system of inequalities. All right. So let's say, and let me unzoom. All right. So we're going like this for my separation. All right. So for inequalities, let's just say we have y is less than or equal to negative 1/2 x plus 4. And the other one is going to be y is greater than, we'll just go greater than x minus 3. Okay, so we have our inequalities. Next thing that we need is our coordinate plane. So let's say, so we're going here, starting there and there. Yeah, we can be like right here. All right, so here's my coordinate plane. And this is the reason why I love the dots, because I can make my graphs so much smoother. Okay, probably don't need all that, but here we go. All right, so when it comes to inequalities, when you have less than or equal to or greater than or equal to, you're going to draw a solid line. So let me put this off to the side here. So less than or greater than, we have a dashed or dotted line. Less than or equal to or greater than or equal to, it's going to be a regular solid line. Okay, and then for the shading, because that's the difference between inequalities, is dealing with the shading. If it's less than or less than or equal to, you shade below. If it's greater than or greater than or equal to, you shade above the boundary line, okay? So if I were to graph, say my first equation, I'm going to graph it in red. I start at the origin. From the origin, I'm going to the y-intercept. So the y-intercept, I'm going up 4, putting my first point. Now, from this point, I'm looking at my slope, just like if you were going to graph a regular equation line, okay? The only thing comes different is the different types of line you're going to draw and the shading. That's the only major difference. So from this point, I'm looking at my slope. Remember, your slope is your rise over your run. My rise in this is going to be going down 1. And my run, since it's positive, I'm going to go to the right 2. So here's a point. I can continue on this path. I can go down 1 and to the right 2. Down 1 to the right 2. Now, with a negative slope, you can read it one of two ways. I can also say my rise may be positive, but my run will be in the negative direction, 1, 2. Okay, I can go up 1, but I can go over to the left 2. Okay, up 1 to the left 2. So now, looking at the inequality, I have the line underneath my inequality. That's less than or equal to, okay? It's not less than equal, okay? It's less than or equal to. So that means since I have a line underneath it, I can draw a solid line through this point, or through these points. I'm just going to throw up to here. Now, the way I would shade, it says less than. So I can shade below this line. If you ever get stuck, use 0, 0. If you use 0, 0 to plug in for your x and your y, you're going to see 0 is less than or equal to 4. Is 0 less than or equal to 4? Yes, that is a true statement. So if the answer is yes, that means I can shade everything below my boundary line, which is this red line that I just drew, except for this little piece that I went a little crazy about. Okay? So now we're going to solve the other inequality. So I'm going to use, I don't know, maybe this light blue. We'll see what that does. All right. So again, if I start here at the origin, I got my negative 3. 1, 2, 3. That's my first point. This is my y-intercept. Okay, that's my home. Now, I need my slope to get to my friend's house. If you don't see anything there, it's assumed that there is a 1 there. But since we're talking about slope, it's 1 over 1. So that means I go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. Okay, up 1 to the right 1. Up 1 to the right 1. So forth. But I can also go down 1 to the left 1. Notice that point is still on that line. But here's the fun part. It says greater than. It doesn't have the line underneath. So that means I'm doing a dashed line. Just draw and pick up. Draw and pick up. Okay? Arrowhead, arrowhead. And now they're saying that it's greater than. Greater than means I am going to shade above. Okay? I'm going to shave above that line. If you're not sure, test it with 0, 0. If I plug a 0 in here, I have 0 is greater than negative 3. Yes, here's 0. Here's negative 3. 0 is greater than negative 3. That's a true statement. So the side that contains that point 0, 0, that should be shaded. Okay? So now, notice there's an overlap between here and here. This whole section. So that means any point in this shaded region where the shades overlap, that's where it's going to be the answer for both inequalities. Okay? I know I bored half of you guys to death. Okay? I'm surprised there's still people here. Because I know I've gone over this so many times. All right? So where it overlaps, that's where your solution is. Okay? That's where your solution is. All right? So that's for that one lovely little person. Thank you. Michael, trust me. I know, that was hard. That was hard. That was hard. That was tedious. Okay? So when you're dealing with inequalities, once you kind of get a grasp of what's going on here, what type of lines you should draw, and where you should shade, that's the only difference between this and a regular equation of the line. All right? All right. So I'm going to wrap up with giving you something really challenging to do. And then I'll be done. All right. I'm just kind of curious to see how many of my trig people are out there. All right. So we want, oh, hey, Lisa, I didn't even know you were here. Okay, homework. No homework. I'm just kind of curious how you guys will do with this. So we have a point, -10 24ths. First off, which quadrant would that point lie? Remember, this is the first. Let me actually put it up here for you guys. This is the first. This is the second. This is the third. And this is the fourth. What quadrant would -10 24ths lie? The first, the second, the third, or the fourth? Hi. Matrices. I didn't do matrices. I didn't get a chance to get to matrices yet. Okay, so we got two, we got second. Hey, Daisy, 2. Good. So roughly, let's say we're going to put this point somewhere around here. I know it's probably not that, but here. So if this point is here, I'm going to draw a nice segment. Now, if I'm trying to find the measures, and I'm going to make this into a right triangle. This is going to be my theta. Okay? My theta, anytime you're probably seeing what I'm doing. But anytime you're doing, your theta is always near the origin. Okay? What will be the length of this side that I'm pointing? What will be the length of that right now? Hey, Alicia. Good. Okay, what would be the length of this? All right, Lisa says -10. Do we agree? Not sure. Remember, question marks are welcomed. Okay, Miranda's saying 24. Okay. Well, we're not doing arc length. It's not arc length. It is your x values. And your x values of this point was -10. So that means the length of this side is going to be what? Okay. You get that point. Okay, so the point was given to us right here. The -10 24. So -10 is going to be my x values. The 24, that's my y values. Okay. So this is my x, this is my y. That's the coordinates of this point right here. So we need to find, in order for me to figure out what the cosine, the sine, or the tangent of this triangle is, I need to find my longest side, which is called the hypotenuse. How am I going to find that? Not a problem. How am I going to find that? Okay. Where are you getting the 13? How am I going to find this longest side? Do you remember? Anybody remember what it's called? A couple people are getting it to me. Yes. Yes. Okay, we got our Pythagorean theorem. Okay, our a squared, our b squared equals a c squared. So we got our negative 10 squared plus our 24 squared is equal to our unknown squared, or the square root of our, to give us our unknown. So negative 10 squared, that gives us 100. Okay, plus our 24 squared. Whoa, I know what 25 is, but I keep forgetting what 24 is. Yep, 570. I should know this. 576. 76ers. Okay, so if we have our 24 squared plus squared, that will give us our square root of 676. That will give us what our x is. And I know 676, that will give us our perfect square of 26. So the length of our unknown side is going to be 26. All right, so now we need to find the cosine, the sine, and the tangent. So remember, cosine is our ca. Sine is our so. And tangent is our toa. Okay? Sine, opposite over hypotenuse, and it's all based on our theta. Cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. So if this is our angle, adjacent means next to. So that means we have negative 10 over 26, which could be reduced. Our sine, based on the theta, sine is opposite. So opposite is 24 over 26, which can be reduced. And our tangent is opposite over the adjacent, which is 24 over negative 10, which can be reduced. But I just want you to guys get the idea. Okay. Good. Okay. Yep. And we could use tangent. That's true too. All right. Okay. So now that I got your brain all stimulated, I love the spelling of Pythagorean theorem. Love it. All right. So, wow. Just before 10 o'clock. Yes. So, just in time for my new students. All right. So, as usual, this was awesome. What we're going to be working on tomorrow, I am not sure. I think some people actually made a couple suggestions, and I might be able to go into that. But we I'll take a look to see what I haven't done. Someone did mention something other than Pythagorean's theorem. And we already did the sine, the cosine. I did arc length already. Matrices. All right, I might see if I have anything on matrices. So, but this is, I'm actually going to be going live early, not tomorrow for you guys, but for my Facebook and for not so much Instagram, but like Facebook and YouTube. So if anything, do a couple things for me, if you don't mind. One, go ahead and follow me if you are just like, yeah, she's not completely crazy and I think she'll be all right. Okay, you can follow me here. You can also, if you want to do a Google review, ACG Math Tutoring, or you can subscribe to my YouTube channel, okay? Most of my lives are there. And I will be connecting all of my notes and the lives onto the notes. So like say for instance, say that we did this today. And then what I would do is I would make a copy of it. And then somewhere on the page, I would have a link that you can click that will show the video that is to those notes. Or there's a QR code that you can just take a picture of it and it'll take you right to the instruction of it. So you'll have the instruction of it instead of just pages of notes. Doesn't make any sense. So I'm going to have that on my website and I'm going to try to put tonight's stuff on there as well. It all depends on how long it takes me to upload everything. And I will be here tomorrow, I think at 8:30 again, if I'm not mistaken. I'm going to try to shoot for 9:30. I know definitely 9:30 on Wednesday because I have some late students, but I got to get with my student that I'm going to have in the next couple of seconds. All right. So if you need anything, if you have any suggestions of what I should be putting up, because guess what? Finals is right around the corner, guys. So if you need assistance with it, just let me know. Okay, drop me a line. If you got a review packet, hey, give me a link to the review packet. Let me take a look at it. I might actually put it here on my TikTok channel. Huh? Who's that? Helping out? What? Okay, so I will see you guys tomorrow evening. I think 8:30. Yes, definitely 8:30. And we'll take it from there. All right, have a lovely evening, afternoon. And remember, you are truly loved. I'm so glad that you're here. And thank you for being awesome. All right, take care now. Bye.